Andromeda is the closest galaxy to ours. It is located 2.5 million light-years away, and it's so remote that getting there seems more like something that would only happen in a science fiction movie than in real life. To get to this galaxy, we would have to overcome challenges so immeasurable that they are difficult to imagine. From journeys of billions of years to spacecraft capable of reaching a small percentage of the speed of light, and artificial habitats with mountains, seas, and forests that travel along with us. In this chapter, we'll explore a fascinating question. How long would it take humanity to reach it? And what technologies would we have to develop to achieve this? Let's get started. If the universe ever forgot we existed, what would remain of us? What would you save? Our greatest ideas or the small warm moments? What memories would prove humanity was worth remembering? That's what the last book explores. A final message from Noah Kaplan, the last human alive. Drifting through space, he writes down everything that made us who we are. The facts, the feelings, the strange, the beautiful. It's created by Hungry Minds, a collective of artists, thinkers, and storytellers who turn human knowledge into art. And this book feels exactly like that. Part diary, part encyclopedia, part time capsule of the human spirit. There's a chapter called Tattoos, Taboos, and Baboons. It sounds playful, but it's profound. A reminder that for all our science and architecture and philosophy, we are still instinct and emotion carved into skin and memory. Then there's Fecundity Profundities. It's about creation, not just life, but ideas. How we build, dream, imagine, and bring meaning into the universe, even when no one's watching. And one page really caught me, a quiet sepia tone section about movies. Not about cinema history, but about childhood wonder. The author writes how Mars Attacks shaped his humor, and how Jim Carrey and How the Grinch Stole Christmas felt like pure magic the first time he saw it. It made me smile because in a book about humanity's greatest ideas, there's this simple reminder that sometimes the things that stay with us aren't the masterpieces, but the weird, joyful, unforgettable memories that shaped who we were. If I had to choose a moment to carry into space, it would be those small, oddly special memories that stay with you long after childhood fades. Each page feels alive, hand-drawn illustrations beside Noah's words. It truly feels like touching a record of our collective memory, a reminder that we loved, wondered, fought, created, and hoped. With the holidays coming up, this feels like the kind of Christmas gift that doesn't just sit on a shelf. It's one that outlives us. A keepsake, a conversation starter, a reminder of who we are at our best. You can find the last book by Hungry Minds through the link below and use Curiosity10 for 10% off. This isn't just a read, it's a legacy you can hold. Andromeda. When we talk about the universe, the distances become so enormous that our minds struggle to comprehend them. An excellent example of this is the Andromeda Galaxy, also known as M31. This spiral galaxy, much like our own, the Milky Way, is our closest galactic neighbor, and yet it is at a colossal distance. Approximately 2.5 million light-years separate us from it. But what does that really mean? A light-year is the distance that light, the fastest known thing in the universe, travels in a year. Nearly 5.88 trillion miles. Multiply that by 2.5 million and you get a figure of more than 14.7 trillion miles. That's about 1.47 times 10 to the power of 19 miles. A distance so great that it exceeds any conventional comparison we can make with terrestrial or even interplanetary distances. To put it in perspective, the farthest spacecraft ever sent by humanity, Voyager 1, has taken more than 45 years to travel a mere 15 billion miles since its launch in 1977. That's just 0.000001% of the way to Andromeda. Even light, which travels at about 670 million kilometers per hour, takes 2.5 million years to reach this galaxy. That is the scale we are handling. And the most fascinating thing is that Andromeda is slowly approaching us at a rate of about 68.5 miles per second. In about 4 billion years, the Milky Way and Andromeda will collide and form a single giant galaxy. If humanity ever dreamed of sending a ship there, it would have to overcome challenges that today seem impossible. We are talking about a journey 20 times longer than the entire evolutionary history of human beings since they separated from primates. A journey that would make trips to Mars or Pluto look like simple local excursions, requiring technology we are just beginning to understand. Speeds of unmanned spacecraft. Now that we understand the incredible distance that separates us from the Andromeda galaxy, a logical question arises. How long could it take us to get there with the best we've launched into space so far? To answer it, we must look at our unmanned space probes, which have reached the highest speeds recorded by human-made objects. Let's start with Voyager 1, launched by NASA in 1977. It is the farthest ship from Earth and continues its path into interstellar space. Currently, it travels at about 38,000 miles per hour relative to the Sun. It seems fast, and it is on a human scale. Still, at 38,000 miles per hour, the journey would take more than 70 trillion years. That's more than 5 times the estimated age of the universe, which is about 13.8 billion years old. Obviously, in this calculation, it is omitted that Andromeda is approaching. If we consider that, the travel time would be approximately 3.9 billion years, which is almost the same time it will take for Andromeda to collide with the Milky Way. At this point, it seems more straightforward to let time take its course and wait patiently for the encounter to unfold naturally, because at that speed, humanity would have ceased to exist long before the ship even approached the edge of Andromeda. Other probes such as Pioneer 10 and 11 or the more modern New Horizons have similar speeds. New Horizons, which flew by Pluto in 2015, is moving away from the solar system at about 36,000 miles per hour, which leads us to virtually identical conclusions. Traveling to another galaxy at these speeds is, in practice, impossible. There's one interesting exception, the Parker Solar Probe, which in 2024 reached record speeds of more than 430,000 miles per hour. But even if we were to take Parker's incredible speed as a starting point, the journey would still be impractical. Today's unmanned probes, while technologically impressive, are designed to explore our solar neighborhood, not to cross the cosmic ocean between galaxies. To even dream of reaching Andromeda, we'll need speeds that make our current probes look like cosmic snails. Luckily, humanity is already theorizing some positive ways to achieve this. Hey Curious Squad, before moving on, be sure to subscribe to our channel, clicking on the notification bell, and leave us a thumbs up so you don't miss out on our daily videos. Advanced propulsion technologies. We already saw that the fastest probes in history would take billions of years to reach the Andromeda galaxy. But humanity does not stop. Scientists and engineers around the world have proposed new forms of space propulsion that, while not yet implemented, do not violate the known laws of physics. Let's look at 3 of them. First is nuclear pulse propulsion, better known as the Orion project. This idea, developed in the 1950s, involves launching nuclear explosions behind a spacecraft to propel it forward. Although it sounds brutal, it is theoretically viable. While it was never tested on a large scale for obvious reasons, such as treaties banning nuclear explosions in space, it has been calculated that a spacecraft powered in this way could reach between 5% and 10% of the speed of light. That's already 1,000 to 2,000 times faster than Voyager 1. At those speeds, the journey to Andromeda would be reduced from billions of years to only about 25 to 50 million years. Then we have the Breakthrough Starshot project, an initiative backed by scientists like Stephen Hawking and funded by tech entrepreneurs. Their goal is not to send giant spacecraft, but chip-sized microprobes equipped with light sails propelled by powerful laser beams from Earth. These sails could reach up to 20% of the speed of light, which would allow them to reach Proxima Centauri, our neighboring star, in just 20 years. If this same technology were applied to reach Andromeda, the journey would take approximately 12.5 million years. Even so, it is an exponential improvement compared to current times. Finally, there are antimatter engines, one of the most theoretical but potentially most powerful technologies. When antimatter meets matter, both annihilate and release an enormous amount of energy, far more than any chemical or even nuclear reaction. If we manage to master this technology, A spacecraft, in theory, could reach 50% or even more of the speed of light. And it is on this intermediate speed, which is 50% of the speed of light, that we are going to focus. Although difficult to achieve, it is theoretically possible with advances in advanced technologies such as nuclear fusion or antimatter. At that speed, a spacecraft would travel about 330 million miles per hour, and taking into account Andromeda's movement towards us, the travel time would be reduced to between 4.5 and 5 million years. Yes, it still sounds impossible, but we are no longer talking about tens or hundreds of billions of years. And when we reach these speeds, an unexpected ally would emerge: temporal dilation. Getting to Andromeda is not a matter of if, but of how long it would take. Now that we have explored the speeds that different types of technology could reach, it is time to compare scenarios and introduce one of the most fascinating phenomena in physics: time dilation. Let's start with the speed comparison. A spacecraft powered by pulsed nuclear propulsion traveling at 5% of the speed of light could arrive in about 50 million years. A breakthrough Starshot-type laser sail at 20% of the speed of light would bring that time down to about 12.5 million years. And a theoretical spacecraft powered by antimatter at 50% of the speed of light would arrive in just 5 million years. Any of these scenarios is impressive compared to current times, but they all continue to exceed by far human life. This is where the phenomena of time dilation predicted by Einstein's theory of special relativity comes into play. According to this theory, time is not absolute. As an object approaches the speed of light, the time for that object slows down relative to an observer who is at rest. This effect is calculated using the Lorentz factor, where v is the speed of the ship and c is the speed of light. For example, at 0.5 c, 50% speed of light, the gamma factor is only 1.15. That means if the trip lasts 5 million years from Earth's point of view, it would be about 4.3 million years for astronauts. In other words, the temporal dilation is minimal. At 0.99 c, 99% the speed of light, gamma increases to about 7.1. The journey is then shortened to about 350,000 years for the crew. Still, that's unapproachable for a simple human being. Only when we reach extremely close to light speeds, say 99.9999999% of c, does the time shrink dramatically. A trip that takes millions of years on Earth can feel like only 10 or 20 years inside the spacecraft. But here's the catch: reaching those speeds today is simply impossible. Therefore, although time dilation exists and is real, we will not be able to take advantage of it in a meaningful way if we only reach speeds such as 0.5 c. For all practical purposes, time inside the spacecraft will pass almost as slowly as on Earth. The consequence is inevitable. The journey to Andromeda will require multiple human generations. It doesn't matter if you travel at 0.5 c, 0.2 c, or even 0.9 c. The relativistic effects won't be enough to prevent the passage of millions of years. That's why, if we really want to reach another galaxy, we need to think beyond the fast ships. We would need a world that travels with us. Generational spaceship. Suppose we accept that even with the most advanced technologies that respect the laws of physics, such as fusion engines, laser sails, or even antimatter engines, it would take us millions of years to reach Andromeda. In that case, we must abandon the idea of a short trip. The dream of astronauts who depart from Earth and arrive in another galaxy is not realistic. So the only option left is to build something radically different: a generational spaceship. What is a generational ship? It is, in essence, an autonomous world traveling through space. This is not a small capsule or research station. We are talking about a colossal structure designed to house thousands or even millions of human beings for thousands or even millions of years. A ship where people would be born, grow, study, work, start families, and die, never having known any other place than the ship itself. Suppose this spacecraft can reach 50% of the speed of light thanks to future technology such as nuclear fusion or antimatter. At that speed, the journey to Andromeda would take about 5 million years. If we assume an average human generation of 80 years, we would be talking about at least 62,500 generations of human beings who would be born and die on board before reaching the destination. This poses not only a technical challenge but also biological, social, and cultural ones. A generational ship cannot depend on external resources. It would have to be completely self-sufficient, generate its own oxygen, recycle water, grow its own food, and maintain the physical and psychological health of its inhabitants for millennia. Regenerative life support systems, hydroponic farms, and internal ecosystem control methods would be needed. In addition, to avoid inbreeding problems, the initial population would have to be sufficiently diverse. According to studies, at least a few hundred individuals and include contemporary gene banks. But this goes beyond biology. To sustain entire generations, the ship would have to be a complete artificial world. Dormitories and laboratories would not suffice. It would need cities, hospitals, schools, parks, seas, mountains, deserts, and inland forests. Environments where humans could have a whole life, where the children and grandchildren of the first crew members did not feel that they lived in a stellar prison but in their home. This vision resembles the famous O'Neill cylinders, rotating structures that generate artificial gravity through centrifugal force and simulate a terrestrial environment in space, as well as the ring-shaped worlds of the Halo video game saga. Yes, the cost, technology, and planning for something like that are astronomical. But suppose we ever want to leave our galaxy and reach another. In that case, we will need a self-sufficient civilization on the move, a kind of interstellar arc that carries all the complexity of humanity through the cosmic void. Traveling to Andromeda is not simply a challenge of speed, it is a challenge of cosmic scale, of generations. Although no current technology can bring us closer in a single human journey, advances in propulsion and concepts such as generational ships allow us to imagine a future where humanity not only survives, but expands beyond its home galaxy. The journey could take millions of years and require thousands of generations. But if humanity continues to move forward and never gives up, perhaps one day we will be there. And what will happen when we arrive in Andromeda? What will we find? Will Andromeda be very different from our galaxy? If you'd like to know what surprises we will find when we arrive in Andromeda, watch this video.